Professor Basu to come. Professor Bhattacharya, we can start?
Yes, of course. Yeah.
Okay. So, very good afternoon to all of you, and a hearty welcome to this valedictory session of the advanced course on neutrons as probes for condensed matter. I would request the participants to mute the mics so that we don't have issue of feedback. When you speak, of course, you can unmute yourself. To start with, I would like to place on record of my gratitude and sincere thanks to the organizers of the entire program, led by Professor Saibal Basu, Professor Yusuf, and Professor Chaplot is here with us, and a few others who have taken time to prepare the lectures and deliver them. It is no small work. We know that you have to do a lot of, if you have to speak to somebody for 1 hour, you have to make preparations for several hours. That is well known. So I am very thankful to them for spending this time, and I think it has been very valuable. We also thank and welcome Professor Gautam Bhattacharya amidst us, the Director SANP, and I am thankful to him for sparing his time to spend some time with the participants of the course and the faculty. I'm happy on behalf of HBNI that I want to mention that this course has attracted participation from across the country. Obviously, it shows that interest in this subject, and also that it's a unique course, not easily available. And we are glad that on a topic like this, which is in which DAE has specifically very high strength, we have been able to share the knowledge with a good number of students across the country. From the statistics, what I understand is around 50 students or 60 students have participated in the program. Some of them very regularly, and they are going to get the participation certificates. Some of them, depending upon their interest, some portion of the program may not be all the 40 lectures, but some part of the lectures, depending upon their research interests. So it is good that for such a topic, we have had around 50 participants. So I also congratulate all the participants and thank them for their sustained interest in this program. Even though today we say that this has become very ubiquitous to join online programs through either Google Meet or WebEx or so many Microsoft Teams or whatever. I still know that there is a challenge involved in all this. You need to have internet going. You need to have good connection. So it is not so simple as we think. But no, I'm happy that we have had the technology part working all through this course. That is really touchwood. We have not had a problem on this. I recall for Professor Gautam Bhattacharya, I want to mention that we had to stop one of the webinars halfway because we were both the video and audio just could not be transmitted because of some network issue. We had once such occasion in the very beginning, but I am glad that in the last 4 or 5 months we have not had such difficulty. One sad point I would say is that we have not been able to see the students in person and shake hands with them and convey our appreciation or advice. We have to do everything online. But my idea of speaking here is only to just tell all the participants, any of you who are not from BARC or not from Mumbai, if you happen to pass by Mumbai, I am sure the organizers, Professor Saibal Basu and Professor Yusuf Chaplot and others will be happy to meet you in case you want to discuss about any subject or take some guidance from them. In fact, I would take the liberty, even though I may not be the correct person to say, that if you want to see the neutron scattering experiment facilities at Dhruva, we can facilitate that. If you are the students who have gone through the course with HBNI, you want to see the physical facilities, you have every right to do it. We will be very happy to organize that. If you pass by Mumbai and inform us a little bit in advance, I'm sure that will add some sort of completeness to your course, because you have gone through lectures, you have done assignments, and you have done finally some YOC, but you have not done practicals, and you have not come to the neutron scattering facility and really seen how it works. That is the only part of the course which is incomplete, and it can be made complete anytime if you choose to do so, because we want all our students to have comprehensive knowledge about everything, not just textbook knowledge. So in case you want to do some trial experiments, in case you want to collaborate with any of the people here, all that HBNI will be very happy to facilitate. And that is the only message I wanted to give as part of my introductory remarks. Now I request Professor Saival Basu to continue.
Thanks, Professor Rao. At the onset, I must thank my colleagues, but for whom this course would not have been possible. And I'm really overwhelmed with the enthusiasm with which this course was made by the participants, the online participants. Actually, we called it advanced because advanced in the sense that this course was sort of designed to on one hand to teach about the technique, the neutron scattering technique. On the other hand, our attempt was that once one goes through the course, he should be able to plan or execute experiments with us. That is the hope, actually, that people will be able to participate in experiment. This technique of neutron scattering is as important as X-ray, I should say, because the X-ray possibly the most all-pervading technique for experimental condensed matter physics. Almost any laboratory will have X-rays, and today we have synchrotrons. The counterpart is neutrons, because neutrons have its own strength. And the biggest strength is that neutrons are very good for low-Z materials. It can distinguish between isotopes. And more importantly, the wavelength and the energy of the neutrons make them very attractive for structure of materials as well as dynamics. Another very large advantage is that neutron is a tiny magnet, so we can use it for magnetic structure. Actually, all the structures that we know about, which we read in master's and bachelor's degree, ferromagnets, antiferromagnets, ferrimagnets, the structures are actually seen using neutron scattering. That's the only microscopic tool which can tell you how to determine the structure of a magnetic system. This course we divided into 4 modules with this aim in mind. The first module was, of course, the basics, nearly 12 lectures and with 2 tutorials. The basics were basically to introduce the participants towards the fundamentals of the technique so that they can grasp the later parts. So the basic lectures were, otherwise it could have been longer, but this is 10 lectures are enough to take you through the rest of the course. That's what the feeling was. And the second module was on neutron diffraction. I wish we could do a lot more on that, because certain aspects of neutron diffraction we couldn't sort of target, like single crystal neutron diffraction, but which is most versatile part of neutron diffraction, which is magnetic neutron diffraction. This was taken up in fairly detailed manner. And actually, Dr. Anil Jain, I must mention that not only he was teaching, it was almost like a homework come discussion sessions where he told people to solve structures using magnetic Rietveld refinement, which is, I would say, is very important for most of the people who are working on magnetism. The third module was on inelastic neutron scattering, and it was taken up by Professor Chaplot, because he is an expert in this field. And this is possibly new to most of the people, because we do structure work a lot, but dynamics using neutrons is little new. But the advantage of dynamics using neutron, one is that you can cover the entire Brillouin zone when you are doing the structure. We do it with the Raman scattering, but only close to the zone center. But whereas this can take the whole thing. And also, there are several techniques in inelastic neutron scattering. One is for phonons, for faster dynamics. Others is for quasi-elastic neutron scattering, where basically you look at slight broadening of the elastic line to understand diffusion in liquids, also in solids. So these are new, and Professor Chaplot is one person who has worked heavily on this field, and he took this third module and taught the people regarding inelastic and quasi-elastic neutron scattering. The fourth module actually a combination of two techniques. So these are also nowadays extremely popular, these techniques. These are small angle neutron scattering, or SANS, and polarized neutron reflectometry, or PNR. These two are taught by Professor V.K. Aswal and Dr. Surendra Singh. These are actually counterpart of the microscopic structure. These techniques, they deal with mesoscopic structures, slightly larger structures where people can see things at nanometer to tens of nanometer, or in hundreds of nanometers. And polarized neutron reflectometry specifically targets structure of thin films. The technique of SANS, which again, small angle, small q, is for large structure, is extremely popular today, not only among physics people, but also among metallurgists, biologists, chemists. This is a technique which is actually a meeting ground for many, many, many researchers. And that's why we thought that that module must be there. And Professor Aswal is an expert in this field. And actually, if we look at the number of users in Dhruva, possibly SANS and magnetic neutron diffraction, these two techniques attract the largest number of researchers from the country. So at this stage, I must also tell you that if any one of you plan to come and do experiments, you can always do that. Dhruva is available to you in the country. Professor Yusuf is around. So if you want, you can apply for beam time. Also, there is a big organization called UGC DACSR, where even you can get money for coming to this place, doing experiments or buying samples. So this is possible. This is the actual target for us. And polarized neutron reflectometry is another technique where actually thin film studies are plenty these days. Actually, devices, we know, after Digens got his Nobel Prize on nanomaterials, and then maybe in 2006 or 7, the GMR materials by Fart and Grunberg that got Nobel Prize. That after that, now it is a real busting at the seams, this field. And so I thought that polarized neutron reflectometry will also be an ideal technique. So these, I will say, typical 4 modules that we taught. I sincerely hope that some of you really benefited. I can tell you that around 20 students, they have attended almost the entire course, and they will be issuing the participation certificate. But more than that, many people attended the lectures module-wise, depending on their own interest. And I must also say that I'm very happy to say that of it, 9 of the students will be given the credits. So we said this is a 6-credit course, and those who submitted all our assignments and underwent the oral examination that we conducted last week, that then they got more than 60% marks, we'll give them credits. 6 credits will be given for them. I can mention it to Professor Bhattacharya that one of your students will be getting the credits, when 3 of your students will be getting the participation certificates. I'm very happy. And the attendance was extremely wide. I mean, there were students from IISc Bangalore, TIFR, IIT Bombay, IIT Patna, Bharatiya University, SINP, I mean, Goa University, Sardar Patel University, Gujarat. So it's really wide. So at least this is, many things are negative possibly for online courses, but this is one positive, I would say, that we can really address a very large and wide crowd, and we could do that. So I'm happy that this course ended well. We didn't have too much of technical snags. I only wish that the students were a little more questioning type. people, I mean, I don't know. In a classroom teaching, I think people ask a lot more questions than in a lecture of this kind. But otherwise, people submitted assignments and I could see that some of them have understood. And so for some of you, maybe who are fresh candidates, it's an introduction. So thanks to the students also for showing your interest. And I hope that in future, you people will be coming forward for specific experiments. And thanks to others.
Professor Yusuf.
Yes, I would like to give my thoughts about this advanced course like this, what was just completed. And as already has been pointed out, the course on this neutron scattering, and it is unique in DAE, that is in the country, because this is the only facility, the Dhuba research reactor we have, where experimental facilities are available, and the course is designed based on that. And I take this opportunity to acknowledge the great initiative taken by HBNI under the leadership of Vice Chancellor, Professor Vasudev Rao, for such a great initiative, because this kind of advanced courses are very much required for many reasons. See, if we see that the students, let us say, if I consider about the MSc students, when they join for a PhD program, what they have, the textbook knowledge, what is available in the textbook, so MSc knowledge they have. After that, they join in a PhD program, and all organizations, they have some kind of 1 year predoctoral coursework, and that is nothing but, you can say it is the advanced version of the MSc course. So again, that is 90% or more, it is what is available in the textbook. Then they start their research activity, and when they join in any program, whether it is a theoretical, computational, or experimental program, so what they learn basically about the methodology in that particular subdomain. So that adds to their understanding or knowledge, I would say, in the vertical direction in the given subdomain of research. So what remains after that for a particular researchers, young researchers, they should know, they should have some lateral knowledge, the interdisciplinary knowledge beyond their what is available so far, what they have gone through by learning the textbook, as well as getting trained with regard to the methodologies, what they are following with respect to their research topic. So in this regard, this kind of advanced courses, it really fills the gap. For example, if I take this course which is just completed, that is the advanced course on neutron scattering, and if I give an example, let us say someone sitting in SINP or IOP or any university system working on magnetic systems, and obviously I can expect that person would be using techniques like vibrating sample magnetometer or squid magnetometer or Kerr effect or specific heat, this kind of technique. But in order to have microscopic understanding for any magnetic system, it is inevitable that one needs to use a microscopic technique, and there neutron scattering, neutron diffraction is the only technique. There is no alternative apart from, let us say, magnetic synchrotron and experiments. So in this regard, this kind of course module, as already pointed out, there's a huge response for this course, and particularly on the magnetic neutron diffraction. So if I take examples from other domains, let us say if one is working on the radiation damage, then obviously one would like to have the integrated understanding, integrated approach throughout the whole country. What are the other facilities available? Let us say one is sitting in the lab, one has only some small accelerator, like if I take example from SINP, let us say Fermi 6 MeV accelerator is there. One is interested in looking at the material damage with but then what is happening in IUAC, or what is happening in even the Peloton BSc TFR facility located at TFR campus, or what is happening at IUC ion beam centered. So this kind of wider perspective, their knowledge can come through only through this kind of advanced courses, the principles of the technique, the application of technique in wider applications. So then only the student researchers will be able to design their research program, not only sitting in the particular laboratory in a more generalized way that will give wider knowledge and this kind of wider viewpoint in a given subject. Say even let us say in theoretical science, if I see someone is doing, let us say, VAS code to do some calculation. But according to me, there are so many computer programs are available, even the molecular dynamics simulation, ab initio calculation, all this general approach should be there. So this kind of generalized course, the advanced courses will fill the gap. It will give more horizon. I would say it will not give on the, sometimes it may add to the vertical growth as well, depending upon in a given subdomain, as I was saying, from the, let us say, macroscopic understanding to microscopic understanding and so on. Let us say we have beautiful facility of synchrotron facility at Indus 1 and Indus 2. If one is working on the structural aspect, whether it is structural biology or the chemical science or the solid state materials or the material science, if one is using only the lab-based X-ray source or the electron microscopy, I think the knowledge, the understanding in the given subject will be very, very limited. So one must utilize this kind of bright source, photon source with high available high space Q resolution, and one needs to plan for that kind of a high-end experiment using synchrotron radiation. And of course, that again gives the opportunity to use further bright sources which are available across the world. For example, through DST mechanism, students or the researchers can go abroad and use certain other big synchrotron facility internationally. So in order to use that, one has to pass through this journey. And this kind of advanced courses give that kind of wide knowledge to the researchers. So according to me, this it is a great initiative that HBNI has taken, and I think we should keep going. And more students, more and more disciplines, particularly interdisciplinary courses, will be more desired, so that not only the science stream researchers, but from the engineering discipline also, they should be able to join. And there are many, particularly places like BRC or DAE, you see a lot of interdisciplinary research which starts with the scientific concepts and it goes to the engineering side. So if a scientist does not know what is the technological other side, for example, I will give an example, for example, quantum technology. Someone may be sitting in a lab doing experiment, let us say, on quantum physics, quantum science, but one should be knowing the other side of this science domain, for example, the quantum chemistry or even the quantum technology. So this kind of advanced courses, that will be very, very effective. And I can see that with time, this will only demand will grow because its utility is very high. And in this regard, this great initiative started by HBNI is highly appreciated. And I wish the success of such courses in years to come. Thank you so much.
So we go to the next step. Yeah. Yes. Yes, he is giving away, and I.
Okay. Hello. So actually, now there is a formality of result declaration. Now, regarding result, there are 20 students participants who have got this participation certificate. I could request 2 of the students, Harsh Bhatt from BRC and Tania Verma from BRC. I requested them to come. So the award, the participation certificates are supposed to be given by the chief guest. So on his behalf now, Professor Rao will hand over the certificates to Harsh and Tania. But before that, I can ask, can you give your...
I think first we should read the names of all the 20
Okay.
because they also
Okay.
need.
So I will also read out the names of the other participants who will be getting the degrees. Not degree, I'm sorry. Much simpler thing, participation certificate. This will be Deepak Dinkar, research student from TIFR. Harshit Agarwal from Banaras Hindu University, PhD student. Then Prasanna Naga Punit, he is a PhD student at Bhattacharya University. Dhanpal Bairua, research student at ISC Bangalore. Ankur Sharma, PhD student at IIT Mumbai. Jayakrishnan SS, PhD student from IIT Bombay. Then Arun Kumar, student from IIT Bombay. Tania is here, Tania Verma, Bhabha Atomic Research Center, trainee. Then Satyajit Jaina, North Orissa University. Yogesh Kumar is Inspire Fellow at BIRC. Then Shubham Lochhab, who is a student of integrated PhD at Material Science Department of ISC Bangalore. Hiren Machi, Department of Chemistry, Sardar Patel University. Then Tawhidur Rahman, who is a PhD student of IIT Patna. Shubhankar Gupta, Saha Institute of Nuclear Physics. Sudeep Chakravarti, PhD student in SINP. Anju K, Department of Physics at Calicut University. Saurabh Kumar, student, PhD student of IIT Patna. Dimple Kumari, PhD student from IIT Patna. Soumya Bhaumik, he is a student of PhD at SINP. Harsh Bhatt, again BRC, he is actually scientific officer at BRC. And Arpita Roy, IIT Patna, research student. They are the people who will be given the participation certificate. And out of them, 9 of them will receive also the credit, the 6 credit course transcript, 6 credit transcript. So that's the result. And 2 of them are present here. So I will request Tania, can you come forward and receive the... Tania Verma. Harsh Bhatt. So, since you are physically present, you can give your comments on the course. I will also request the students who are there, who are attending this valedictory function, if someone of you want to speak, please let us know. Yes, raise your hand. Yes. So, Tania, if you want, you can say, what do you feel about the course? You switch on the mic and then say.
Sir, it was completely a new domain for me. I learned a lot, and the lectures were also, first they covered the introductory part and then smoothly it moved on. So it was a great experience for me, and I feel that it was a great opportunity to learn as a fresh student.
Harsh, you are in the field of neutron scattering. So maybe you can give your comments.
Yes, sir. So, I think when a student has to learn a new thing, it can be very intimidating. And to learn a new thing, the best atmosphere is the classroom atmosphere. And this course exactly provided that classroom atmosphere for learning a new technique, a new whole technique of neutron scattering as a whole, where we started from very basics, and we then compiled layer by layer and got a very comprehensive idea, starting from the basics of neutron scattering towards the implementation of experimental implementation of all the techniques, which was I think a very nice thing. and it would have motivated many many PhD students to incorporate neutron scattering into their research, and also the existing users to understand the results in a better way. And also someone like me who is working in the field for some time now, who is working in one specialized domain of neutron scattering, to get a perspective of overall, like the overall picture of neutron scattering, different techniques as a whole. So I think this course was a very nice combination for starting from a student who is completely new towards some experienced users of neutron scattering also. So I think that this course should like even continue in future also, so that other new students can also be benefited from this one. And I would like to really thank Dr. Basu and HBNI for like organizing this course. And I would like to thank all the professors who took time from their schedule, like Professor Yusuf, Professor Chaplot, Professor Anil Jain, Professor Aswal, and Professor Surendra Singh, who took time and put in their effort to make this new technique available for the students. So thank you.
Thank you. And I find that somebody has raised the hand from the participants. We'll go to him. But before that, I want to mention to all the students who are with us here as well as online that recently we formed a Research Scholars Forum of HBNI. It is a forum of all PhD research scholars across all CIs to interact. And we have obtained nominations from each center, from BRC, from IGCAR, from RRCAT. So we have a group of people who are all research scholars. One of the expectations for this forum was that they will interact with each other and come back and tell us which kind of advanced courses will be of interest to others, which they want HBNI to organize. This input we need from them. We may have certain idea that this may be good for the students, but students may be, because a good number of students of ours, they are also non-employees and they are going to go out. So they may like to learn new things, which may benefit in the future. They may have some career in mind for which they may like to have some additional information. So we look forward to feedback from research scholars, not just about this course, but also suggestions for new courses. So you are welcome. I think Professor Yusuf can give the names of the other four, the representatives of the forum in BRC. Please interact with them and ask them to interact with others and come back to us and suggest what courses they expect. And we will see how we can do that. Thank you. Now, Mr. Anurag, can you just locate the person who has raised the hand? We can ask him to speak.
Sir, am I audible?
Yes.
Yeah. Good evening, sir, all of you. I'm very much thankful to you, sir, the Basu sir, and HBNI for providing this excellent
Can you identify
course.
yourself first? Can you identify yourself first?
Yes, sure. I'm Deepak Dinkar. I'm a research student at TIFI. So, sir, actually, hello.
Go ahead.
Some voice connection. Yeah, fine, sir. Thank you, sir.
No, it is
so,
fine.
I have actually. Thank you, sir. Yeah, I actually attended many courses through all IITs. I think so. I have attended more than 50 courses, sir, 50 conferences and workshops. So till now, I didn't find any such course that this course actually has the course, the content of course, and more important thing, the comprehensive way of delivering the excellent, truly excellent. It was not like a kind of formal course or like I know, sir, there are many courses I have seen that was just for the APIS course and making kind of things. This is out of that. The course actually I feel in all the way. So the more important thing is that the professors who taught us the courses, they no doubt they were the expert in that field, particularly Chaplot sir and Jan sir, how taught thoroughly. Even I remember the ritual refinement of actually he was doing as we students try to do the things and find the things like, so he started from the very scratch and teach it and taught us each and everything, minute thing of the ritual refinement and how to define a magnetic structure, to develop these all things. So I felt really, sir, overwhelmed and truly fortunate to attend this course. So thank you very much, sir. And I hope, sir, and as the in the very initial remark, sir has already said that the only part which left in the course, that was the experimental setup. We didn't actually was there and didn't witness that how really we perform that neutron scattering and related all the techniques like. So really I'm very hopeful that very soon I will get the chance to interact with you there and will get the chance to perform there also for some of my samples if possibly, sir. So thank you so much, sir, for all of that. So yeah, I just that is my submission. Thank you, sir.
I can respond as VC already pointed out that Dhuba visit is always possible, but probably just
Yeah,
when total lockdown goes. So you can all write to
sure,
me, so we can arrange that visit,
sure.
and not only visit, you may carry out some experiments as well.
Yes, sir. Sir, you are one of the persons, sir, actually who triggered actually this course into my mind. Actually, you delivered a course, you delivered a talk in TIFR, sir, where I found such interesting thing like people are doing magnetic structures also in the neutron refinement like that, which actually was included in your talk. So that was also influenced me a lot to study more into this field. Yeah, thank you, sir.
Yeah, there's one more person. I think kindly be brief because we want to complete this program by 5 o'clock and we are yet to hear Professor Bhattacharya. Can you identify yourself and speak if there's anybody else? I think we'll hear him later. We will proceed with the program probably because we are running a little short of time. Yes. Now may I request Professor Gautam Bhattacharya to address the participants and all those who are present here. We are thankful to him for sparing his time and we would like to listen to his perspectives about such courses and any suggestions. Professor Bhattacharya.
Am I audible? Can you hear me?
Yes, yes, very well.
Okay. So first of all, I thank Professor Basudev Rao for inviting me, and I was pleasantly surprised because I'm neither a nuclear physicist nor a condensed matter physicist to be invited in this particular context. But I feel humbled and honored to be given this opportunity to speak to you, especially in front of the students. Now, before I share my perspective, I thank the entire team of teachers, Professor Chaplur, Professor Yusuf, Professor Saibal Basu in particular, and Professor Ashwal and Professor Jain and others, whoever have lent their hands to make this course a success. I can pretty well see how the students enjoyed and enriched from this particular course. Now, frankly speaking, I mean, neutron is not anymore a matter of nuclear physics alone, as is pretty clear from the content of the course and the way the students appreciated and got enthused about the course. It's clear that, I mean, people from all disciplines can use neutron as probably one of the most domesticated element. I mean, they can use for any purpose. Now, I mean, in this context, since I don't have much to say about this particular scientific details of the course, I would, share my personal reminiscence about how I learned a little bit more about neutron, increasingly more as I went along my career. I mean, as probably most of you, I mean, I learned about neutron in it's about how many years back when we were doing our BSc, I mean, Bachelor's of Science, through a course of what in those days used to be called a course on modern physics. I mean, they were not so specialized. And then, frankly, I was personally got very interested about nuclear physics in a long break that we had in Kolkata, because the university, the BSc result used to be published maybe 8 months after the exam, and we had a long gap. I mean, in that break, I got I became a member of the British Library. Now, I used to read books about many other things, not much about science, but one of the interesting books I read was an interview by Laura Fermi. Is an excerpt from Laura Fermi's interview. She was Fermi's wife, Enrico Fermi's wife, of course, it's clear. And she recounted how in 37 or 38, in a conference somewhere in Europe, Rutherford told Fermi that you are likely to get Nobel Prize this year because of your work on slow neutrons. Now, Fermi made up his mind, and of course, Fermi got Nobel Prize in 1938. And he made up his mind to leave Italy, because at that time, I mean, because of his wife's Jewish background, the family was kind of in a state of danger because of Mussolini's regime. And when Fermi and his friends were, Fermi and his wife were leaving for Stockholm, and his friends came, and only they knew that Fermi would never come back to Italy, in Roma Termini, I mean, in Rome. So, I mean, the reason I'm going to tell you, I mean, so then the story goes on telling how Fermi landed in US and how he got many more students. And you see that Fermi's work on slow neutrons not only heralded a new chapter in nuclear physics, but in many other branches of science, as you would see. And some of Fermi's students, they became Nobel laureates later in high energy physics, and like Jack Steinberger, T.D. Lee, C.N. Young, they all were trained by Fermi. And then when I got, enrolled in our MSc program 7 or 8 months later, one of our teachers in nuclear physics was a student of Fermi's student. So his name was Professor S.N. Ghoshal. He did his PhD with Emilio Segre, and Segre was Fermi's student. I mean, Segre left Italy, and he went to radiation laboratory lab in Berkeley. So he became a professor in Berkeley. He got Nobel Prize later. And Professor Ghoshal, who, slowly I got, because of my, reading of Laura Fermi's book, I was interested in nuclear physics. And then I found a teacher who was Fermi's grand student. And I also got to know that Professor Ghoshal did a famous experiment, and which got published in 1950 in Physical Review. That was the experimental verification of compound nucleus theory. I mean, that was a very fundamental piece of classic work of bombarding nickel 60 with alpha particle, which will become a compound nucleus of zinc 64. I mean, that was one of the first, experimental verification of compound nucleus theory. And when the paper got published, I looked at that paper, at least the abstract. I mean, it says his address to be University of California at Berkeley, the radiation laboratory lab. And also, by the time it got published, he was a member of Institute of Nuclear Physics, which is the institute where I presently belong. And in 1950, it was not Saha, and Saha was pretty much alive. It was an Institute of Nuclear Physics, which was a part of Calcutta University at that time. So that sort of thrilled me, in a sense that I could connect many things together, bits and pieces together, to make the complete history. And, Professor Ghoshal didn't take many classes, but I mean, he was a kind of inspirational teacher in a part of our MSc program. Now, then somehow my career went in a different path. I didn't become a nuclear physicist. I worked on high energy nuclear physics called particle physics. And there also, in my personal research, neutron anti-neutron oscillation played a role, in a sense that, neutron has a baryon number. It is a baryonic matter. Like proton, it has a baryon number. So if, like neutrino oscillation, it is in principle possible to have neutron oscillation. Now, but that will violate baryon number, and there are pretty stringent constraint on violation of baryon number, and you can put a constraint on any process that violates baryon number, like what happens in what is called supersymmetry, for example. It is a very high energy speculative physics. Now that has not yet been experimentally verified. So it's something I spent probably 80% of my life on. And so neutron is useful in many different ways. As you can see, that it can sense things which might have happened near the grand unification scale, maybe a baryon number violation. And as you have heard from Professor Soibal Basu, that because in cold neutron or thermal neutron, the wavelength, which can be of the order of angstrom, like for a MeV range neutron, which is like the interatomic spacing, so it can probe the material properties also very well. And also, he mentioned that its energy, like mentioned, the kinetic energy is comparable to that of atoms within a solid. So in a sense that it can resonate. So in principle, it can probe the material properties, not only because of its wavelength, also because its energy is similar to that of atoms in a solid. Moreover, through its magnetic moment, although neutron is electrically neutral, it has a magnetic moment. It can sense, it can see the unpaired electrons. So in many different ways, as he mentioned, that it is kind of a reincarnation of the X-ray usage of X-ray. I mean, neutron scattering can, shed a lot of light on material properties. So it is not only useful for nuclear physics, it is not only useful for high energy physics, it is also useful for material science and everyday life. Now, well, I mean, as you might have all read about neutron in the context of radioactivity, right? And we know that weak interaction is the driving force behind radioactivity, and it is because of weak interaction that the sun shines and we get the light and energy that is needed to for life to be possible. So not only that, I read somewhere that for cancer therapy, to kill the same number of cancerous cells, you need 1/3 the number of protons that you need for the neutron. So if for X number of protons you need 1/3 X number of neutrons to kill the same number of cancerous cells. So in 1932, when Chadwick discovered neutron, little did he know that one day, I mean, maybe 70 years, 80 years down the line, it will be used for medical therapy. So you see that it's kind of an all-weather ally of scientists. And as I mentioned, it is probably one of the most domesticated element. Like now the scientists can make it talk for their own need. I'm sure many of our colleagues and I'm sure the fellow students are fond of cricket, being an Indian. So this morning, James Anderson made the ball talk, right? I mean, the Indians reeled. And so the more you get to know about the neutron, you can make it talk. I mean, like what Yusuf said, I mean, you come to his lab and he can show how it is useful. Dr. Chaplot will also show you how it is useful in his lab. So you guys are really fortunate that you got trained by some of the experts who are practicing experts in their own field. And I'm sure that, I mean, although this year, because of the pandemic, you got introduced to this course through online mode, I mean, you are already invited to visit their labs and, see the experts in action in their own backyard. And that you will see, when you see them, live, and you will see how exciting, how interesting it is. I just wish I were 30 years younger to be one of you and to have been fortunate to visit those labs. And in my time, I mean, of course, maybe it is because of my ignorance or so. I mean, we didn't have that much exposure, but I'm sure that these days, I mean, there is a lot more exposure for possibility of being exposed to the highest quality of technical training than was available in those days. And in the last 30 years, the subject has moved a lot. It is now in your backyard. I mean, now, you don't have to be a scientist to know about the neutrons. And for example, many of you, I mean, I'm specifically addressing the students, you don't have to be a neutron specific scientist wherever you end up. I mean, it's a long change. I mean, starting from fundamental physics or mathematics all the way down to real life applications, somewhere you will fit. And the knowledge that you gathered through these courses from the masters who are the best craftsmen in their own game, and you will see, and hopefully you will see them in their backyard, and you will be inspired to by their activities and by the way people think about research and application. And I'm sure you will fit in a very good way to help us in the society, to be useful for common men like us. Thank you very much.
Thank you, Professor Bhattacharya, for your interesting thoughts. I'm sure they would have provoked a lot of ideas in the minds of the participants. I want to respond to you just by adding that only yesterday we have started the next advanced course, and that is on nuclear science and technology, to provide a broad overview of something about nucleus, starting from nucleus, again starting from basics, going into applications of radioactivity and nuclear radiation for various domains. So this is again another 40 lecture course, and this again is being delivered by experts who have done experiments themselves. So I'm sure this will also be of value, and we have already registered a good number of students, and we look forward to suggestions for organizing more such courses as we go along. And one thing is sure for me, that the situation has changed so much that I do not expect any course to be fully physical participation in future, because people have realized the advantage of this distance education, or whatever you call it, online learning, etc. So I think the most likely thing to happen will be a hybrid course, where some 10 or 20 lectures will be delivered online, but one part of the program we bring the students together to get hands-on experience and discuss some assignments across the table with the teachers, so that we are able to give the total perspective. So I think this is a hybrid thing, is likely to be the thing of the future. We will attempt it when the situation becomes more amenable for this. So with this, I would like to thank Professor Gautam Bhattacharya, and I request our Dean, Professor P.D. Nayak, to just say a few words and a word of thanks.
Good afternoon to everyone. It is my privilege to propose a vote of thanks to all resource persons, coordinators, our today's chief guests and other things. This course was inaugurated by Professor R. Sitamaram, all of you know, former Principal Scientific Advisor, Government of India, and former Chairman, Atomic Energy Commission. I, on behalf of HBNI, would like to thank him for encouraging us to conduct this course. I extend a very hearty vote of thanks to Professor S.M. Yusuf, Director IOP, and Professor Gautam Bhattacharya, Director SNP, for considering our request in spite of their busy schedule to grace this function. I would like to thank Sri K.N. Vyas, Chairman AEC and Secretary DAE, Professor S. Banerjee, Chancellor HBNI, Professor P.R. Vasudev Rao, Vice Chancellor HBNI, for their keen interest in providing valuable input for this course. Of course, this course was possible because of efforts put by our coordinator, Professor Saibal Basu and Professor S.M. Yusuf. They have not only conceptualized the idea of this course, they made the syllabus, they have selected the resource persons, and also conducted the course in very, very friendly manners. We can see from the comments made by the students. Students like the way the course was conducted. especially Deepak Dinkar was really thrilled that this type of course should be continued. I also extend thanks to all the resource persons. Professor Cyber Basu itself, he is also, apart from conducting, coordinating this course, also given the lectures. Professor S.M. Yusuf is also coordinator, but he also taken the classes. Professor S.L. Chaplot, always known as a very, very good teacher and thorough knowledge in the field in which he is working, and one of the best reviewers of the papers. In fact, you got many best reviewers of papers award and other things. Professor V.K. Aswal, Professor Anil Jain, Professor Suren Singh, all of them put the efforts to make this course really useful for the students by taking from the stress up to the level where the student can themselves can understand about the how to perform the experiment and how to analyze the data. We are fortunate enough to be backed by HBNI, Center Office Functionaries, and we are also having a team of dedicated IT resource persons. And this was possible because of their efforts and their help time to time whenever there was some technical snag and other things. This course is now was conducted online, and as Professor Vasudhara Rao suggested, the future course will be like a hybrid type of courses, and where wherever required, like a one-to-one discussions and experimental parts, student can come to HBNI or CIS and OCC and can have interaction with the faculty as well as can perform the experiment. And we're going to plan once things are becoming normal, maybe after the next 6 months with grace of God. I wish to thank all the participants and wish them all the best for their career in research. And thank you all.
So thank you, everybody. And if any other comments or observations from anybody else, we would listen. Otherwise, we say bye for the moment. And we look forward to future interactions.
I would like to tell something. Since
Yes, Prof,
since SNP people are there, I would like to propose them a course on biophysics, which will be on online courses from SINB, biophysics course. I have heard that those courses are excellent. Maybe, at the basic level to whatever it goes, the way it goes. What course from SINP on biophysics would like to see?
Good. I would try to do the needful. Professor Bhattacharya is also here.
Yes. We will talk about with our colleagues and get back to you. Definitely.
Surely, it could be done. Good proposal.
Okay, thank you very much.
Okay,
Definitely, yeah. Primarily on cancer biology. I mean, that is where the expertise lies.
Yes. Thank you, and we complete this meeting here, and wish you all the very best once again. Thank you.
Thank you very much.